Hey everyone, Cody again, here for the interactive concept presentation number 7, I believe. So we got some balloons that we blew up, have them all set kind of behind me, and the reason we did that is so we can go over the geometry of molecules, valence shells, and number of domains, and lone pairs, and all that good stuff. So we'll just start right off the bat and start with the shape here of the first one. That's linear. You can see the molecule here represented by the atom here in the middle, and it's kind of in a linear shape. I wonder why it's called linear. The bond angle here is 180 degrees. So if we took like a protractor or something, that's a straight line, 180 degrees, represented by this shape. So the type is an AB molecule. It's got 0 alone pairs, and examples would be like O2 or HF, sodium chloride, N2. Yeah, so that wraps it up for about everything linear. Next, move to trigonal planar. So tri meaning 3, planar meaning flat, so you can kind of see like with the atom being in the center, and then our shells being flat, kind of like, not like in a pyramid or like a tetrahedron or anything. So this is the planar one. The bond angle here is 120 degrees, right? So it's not quite 180, but it's 120. That's for all sides. And then the electron domain here is 3. The type is AB2 here. There is one lone pair in this trigonal planar formation. So examples like this would be like CO3 and NO3. And that about wraps it up for trigonal planar. So next is the tetrahedral, or tetrahedron, or tetrahedron. I can never say it the right way, tetrahedral. There we go. So the bond angle here is about 109.5 degrees for each one right here. And why is it called a trigonal? What's the difference between trigonal planar and tetrahedral? Sorry, what's the difference between tetrahedral? This is because it makes kind of like a 3-dimensional pyramid, right? Because there's 3 sides to it. It's not like here where we've got just kind of a 1-dimensional triangle. Here we've got kind of like a 3-dimensional going on here, because any way I turn it, it makes a triangle on all sides. So the electron domain here is 4, and the type of molecule is AB2 and AB3 molecules. Lone pairs is 1 to 2, depending on the molecule. Examples are like phosphate, PO4, and sulfate, SO4. So that wraps it up for the tetrahedral. I can't say it right. Next is the trigonal pyramidal. Did I just do that one? Oh, maybe I did that one. Okay, well this is the trigonal, never mind. Everything I just said for that one, tetrahedral, maybe that's this one. No, because this is trigonal planar. Well, this is going to be trigonal pyramidal. The bond angle is 90 degrees and 120 degrees. Electron domain is 5. The type is AB2, AB3, and AB4. Lone pairs are 1 to 3, and examples for that one are ammonia. So I'm not sure what I got wrong here. I think I might have got my notes and balloons mixed up, so sorry about that. Next is octahedral. Oh, there we go. This is what it is. This is our trigonal pyramidal. So yeah. So this is the tetrahedral. This is trigonal pyramid, because there's one extra. You can see kind of like, whoop, one extra. All right, now we got that straightened out. Next is the octahedral. The bond angle here is 90 degrees, because every which way it makes about a 90 degrees. The electron domain here is 6. The type of molecule is AB4 and AB5. There is 1 to 2 lone pairs depending on the molecule, and the examples here is sulfa hexafluoride. So yeah, really interesting to kind of visualize molecules, atoms, valence shells, the geometry of them, how they bond together, and why they make the shapes that they do, and what the certain shapes mean. So researching that was all pretty interesting. You know, because it's one thing to read something on paper, but it's another to conceptualize it, especially with something so hands-on that you can visualize and kind of see what it's talking about when it's talking about bond angles and talking about the electron domains, because you know, those domains of 6, because now I can count out 1, 2, 3, 4, 5, 6, and oh, that's what it's talking about. So overall, really cool. Sorry about the mix-up with the trigonal planar and then the tetrahedral, you know, these two right here. So glad I could correct that. Looking forward to next week's presentation. Thanks. Bye.